There is a planet in our solar system that should not exist the way it does. It sits closest to the sun. It should be the most predictable place in our solar system. One temperature, one story, one simple fact. It's hot. That's it. Case closed. Except it isn't. Because on this planet, only a few hundred kilometers separate a place hot enough to melt lead from a place cold enough to hold ice. Real ice. On the planet nearest the sun, this is Mercury. And the more you look at it, the less it behaves like a planet, and the more it behaves like something that survived a disaster and never fully recovered, carrying the scars, the imbalance, and strangely, the resilience everywhere it goes. Let's start with the part that sounds impossible. Turn Mercury's face toward the sun, and the surface can reach 427 degrees Celsius. That's 800 degrees Fahrenheit, hot enough to melt lead like it was ice cream left out in the sun. Now, turn to the other side, the side facing away, and the temperature collapses to minus 179 degrees Celsius, minus 290 Fahrenheit. Cold enough to make Antarctica look mild by comparison. In fact, it's colder than your home freezer, not by a little, but by roughly 9 times over. Same planet, same rock, two completely different worlds, separated only by which way it happens to be facing, and here's the detail that breaks the pattern completely. At Mercury's North Pole, hidden in permanently shadowed craters where sunlight never reaches, there is ice. Actual water ice sitting quietly on the planet closest to the sun in the entire solar system. Most people don't realize this contradiction can exist. Closest to the fire and still holding frost. So the natural question is, why? Why would the nearest planet to our star behave like it's living two separate lives? To answer that, we have to go inside Mercury, not just look at its surface, but understand what it's actually made of. Most rocky planets are, unsurprisingly, mostly rock. Mercury isn't. Roughly 70% of Mercury is metal, only 30% is rock. That ratio is unusual enough that scientists essentially describe Mercury as an iron ball that has been sitting in the sun's heat for billions of years, wearing only a thin coat of stone. That composition makes Mercury incredibly dense, 5.427 grams per cubic centimeter, the second densest planet in the entire solar system, beaten only by Earth. To put that in perspective, Ganymede, Jupiter's largest moon, and Titan, Saturn's largest moon, are both physically bigger than Mercury. Bigger, but lighter. Less mass packed into more space. Mercury is smaller and heavier, a compact, dense core wrapped in almost nothing. And that raises the real question. Why does a small planet have this much metal and this little rock? The leading scientific explanation, and it's important to be clear that this is a hypothesis, not a confirmed fact, is that early in the formation of the solar system, something massive collided with Mercury at extreme speed, not a graze, a direct planet-altering impact. The theory suggests this collision blasted away most of Mercury's outer rocky shell, stripping it down to what was left, the dense iron core underneath. If that's true, then Mercury isn't just a planet. It's what remains after something tried to destroy it and didn't quite finish the job. You can actually see the evidence of a violent past written across Mercury's surface. It is covered in impact craters, but one stands above the rest, the Caloris Basin, a crater roughly 1,550 kilometers wide. To put that into scale, that's wider than the distance from Los Angeles to Denver, punched into a single planet by a single impact. That collision didn't just leave a hole. It triggered lava flows that formed ring-shaped mountains rising up to 2 kilometers high. And here's the part that sounds almost fictional, but is documented. The shockwave from that impact is believed to have traveled through the entire body of the planet and disrupted the terrain on the exact opposite side. Scientists gave that region an unusually direct name, weird terrain. Not a poetic label, a literal description, because nothing else quite fit. So we have a planet with a metal heart, a shattered outer shell, and craters recording a violence that shaped it billions of years ago. But we still haven't answered the original question. Why the extreme temperatures? Here's the layer most people skip past. Earth has something Mercury doesn't, a thick atmosphere. Think of it as insulation. During the day, Earth's atmosphere absorbs heat. At night, it slowly releases that heat back out, smoothing the difference between day and night into something livable. It's a buffer, a cushion between two extremes. Mercury has almost none of that. What it does have is called an exosphere, a layer so thin, so sparse that the particles in it barely ever collide with each other. They can't circulate heat, they can't hold it, they can't protect anything. Every time solar wind sweeps across Mercury, it strips away particles from this fragile layer and drags them into a tail stretching tens of millions of kilometers behind the planet. In images captured by the Messenger spacecraft, Mercury doesn't look like a planet at all. It looks like a comet. No atmosphere means no insulation. No insulation means no middle ground. Just extremes, directly exposed, with nothing standing between the surface and space. But here's where Mercury does something you would not expect from a planet this damaged. Despite a shell that was likely blasted away, despite a surface record of catastrophic violence, Mercury still has something Mars, a planet that never suffered anything close to this, does not have. A real, measurable magnetic field. It's weak, only about 1.1% the strength of Earth's, but it's real, and it's enough to deflect part of the solar wind. Scientists believe this magnetic field comes from a liquid iron core still moving beneath the surface, meaning that somewhere underneath all that damage, something inside Mercury is still active, still generating force, still, in a strange way, alive. A planet that got hit hard enough to lose its outer shell, and somehow its interior kept moving anyway. Now, here's the part almost nobody expects. Maybe you didn't know this about Mercury's orbit. Mercury has the most eccentric, the most stretched, uneven orbit of any planet. At its closest to the sun, it's about 46 million kilometers away. At its farthest, about 70 million kilometers. That's a swing of over 50% in distance within a single orbit. It also completes that orbit incredibly fast. Just 88 Earth days to go around the sun once, the fastest of any planet. But here's the twist. It spins on its axis extremely slowly. It takes 59 Earth days to complete a single rotation. That relationship, 88 days to orbit, 59 days to rotate, produces something called a 3 to 2 spin orbit resonance. For every 2 full trips around the sun, Mercury spins exactly 3 times on its axis. It's not messy, it's not random, it's precise, almost mechanical. And this creates something genuinely strange if you were standing on the surface. Because of that ratio, a single solar day on Mercury, from one sunrise to the next, lasts 176 Earth days. That's the equivalent of 2 full Mercury years. One day, technically, longer than 2 years combined. But here's the detail that sounds like a glitch in reality. Near perihelion, the point where Mercury is closest to the sun, its orbital speed actually becomes faster than its rotational speed. If you were standing in the right location on the surface during that window, you would watch the sun rise, slow down, stop completely, and then move backward, reverse itself in the sky, then, after a while, resume its normal path forward. Not an editing trick, not a metaphor, a real, physical, observable event caused entirely by the mathematics of speed and rotation. A sunrise that hesitates, stalls, retreats, then decides to continue. There's something worth sitting with here, beyond the physics. Mercury has no atmosphere to soften its extremes, and as a result, it swings between conditions that would instantly kill anything unprotected. Earth's atmosphere isn't just weather, it's a buffer system, quietly absorbing shock so that extremes rarely become fatal. Most people never think about how much of their own stability works the same way. Habits, relationships, routines, a sense of identity, these often function less like decoration and more like an atmosphere. Not exciting, not always visible, but doing the quiet work of keeping day and night from becoming unsurvivable versions of each other. Remove that buffer and you don't get freedom. You get exposure. Mercury shows what that looks like in physical form. A planet with nothing standing between it and the full, unfiltered force of its environment. And yet, it still has a working magnetic core, still moving beneath the surface, still generating something, even after losing almost everything on the outside. Maybe that's the part worth remembering more than the temperature numbers. There is one more image worth ending on. At some point during its mission, the Messenger spacecraft turned its camera away from Mercury and photographed Earth from Mercury's orbit, tens of millions of kilometers away. In that photograph, Earth isn't a blue marble. It isn't recognizable as a planet at all. It's a few pixels, a faint point of light, barely distinguishable from noise. And inside that handful of pixels was everything. Every person who has ever lived, every city, every argument, every quiet moment, every war, every love story, compressed into a smudge of light so small it could be mistaken for a camera error. Meanwhile, Mercury, a battered, metal-hearted planet that lost most of its outer shell billions of years ago, that swings between fire and frost with nothing to soften the difference, simply sat there, still turning, still holding its shape, still watching in its own silent, scorched way back toward us.